We are finally at the core of MATLAB, the matrices. A matrix is another way of storing data, but it allows you to store it in multiple dimensions. The most trivial example is x and y, columns and rows. Two-dimensional matrices are simply tables of data. Let's take our protein example from previous lectures. If we use a vector, we can store the data about our protein intake for a given amount of time. What if we want to extend that information and also have our carbs, fats, calories, vitamins? We need to create new and new vectors for each of these sets of data. This is where matrices come into play. Matrices consist of either vector rows or vector columns, but they are two-dimensional. We have two dimensions, rows and columns, and they become two-dimensional as soon as either of the dimensions has a size of more than 1. If either of these dimensions is of size 1, then we have a vector. So, vectors can be described as one-dimensional matrices, but the opposite is not true. Matrices are not multidimensional vectors. Again, what does MATLAB mean? It means matrix laboratory, not vector laboratory or math laboratory. So, pretty much everything in here is or can be thought of as a matrix. And this is the key moment for you. I said in the vector lectures that you need to start thinking in vectors. Now I am telling you that you need to start thinking in matrices, and as soon as you do this, as soon as you gain a little practice, you'll realize that there are no limits. Matrices can actually be multidimensional with more than 2 dimensions. They can have 3, 4, 5 or more dimensions. We will not dwell into this yet, but I just want to inform you of their limitless capabilities. Think in matrices. Got carried away a little. So, with the protein example, when we want to add new information, we have to add a new column, because columns represent the days, and we are recording data for each day. We can of course change this vector so that we add new rows instead of new columns. It's the same vector, the same information, it's just that we change whether we are working with rows or columns. An example of a matrix is the days of the week and the hours of each day as columns. So the days will be rows and the hours will be columns. The new information that will be added to the matrix is added for each day. So if you choose your columns to represent the days, you will add new columns. If you choose your rows to represent the days, you will add new rows. You will eventually choose whatever feels better and easier to work with. There is no right or wrong way to do it. But what I recommend that you do is to go for adding new values as columns. So day 1 is column 1, day 2 is column 2, day 15 is column 15. Columns represent the x values, and for me it's much more intuitive to have new values added as columns because we are used to having y as a function of x, and that is exactly what you do when you add new data as columns. If you switch it around, x becomes a function of y. When we start talking about loops and matrices, it is a common practice to have your outer loop iterate over your rows and your inner loop iterate on your columns, which means that you will be working on the matrix row by row. First the carbs row, then the fats row, then the calories, etc. If you switch it around and you make your x a function of your y, your columns a function of the rows, you will still be able to plot it correctly and to loop it correctly by switching a few things, but it's just not as intuitive for me. That brings us to how exactly are we going to create a matrix in MATLAB. Since each of the rows in a matrix is a vector, we start off just like we do with vectors. We separate each of the elements of the row of the matrix either by a free space or by a comma, and when we start on a new line we use a semicolon. Let's see an example. Let's create our diet tracking matrix. So diet track equals, now square brackets, our first row in the matrix will be proteins. So let's give it some values for proteins: 123, 140, 160, 145. Now this is our first row in the matrix. If we want to create now a second row, we are going to use a semicolon. The semicolon indicates that we are starting a new row. The next row will be carbohydrates. So 250, 260, 280, 366. Semicolon. Now we have two rows in our diet matrix. Let's close the square bracket and run it so that you can see that we have one row, second row, with the values separated by a semicolon here. Now let's finish adding it. We are also going to add fats and calories. So the fats are 70, 65, 68, 72, and calories are a bit more, of course. 1850, 900, 2150, and 9099. Alright, now let's run the code again, and there we have it. We have a matrix with 4 rows, each representing a different kind of data. It doesn't say here this is protein, this is carbs, this is fats, but you know it because you created it. Each of the columns represents each of the days. If you want to add new information about your diet for your 5th day, it will materialize as a 5th column. So if you want to add new data for your 5th day, you would simply have to add one new value for each of the rows. So for example, 150 here, 300 here, 70, and maybe 2000. Let's run it, and there we have it. We have a new column. Now I will show you one other thing. As you probably know, by using 3 dots, consecutive dots, we can continue our code, same row of code on the next line like this. I'm going to do this because I want to show you the matrix in its form when we have it as a matrix, literally as a matrix. Now we usually don't do this. I'm simply going to copy and paste it from the example that I prepared. If you want to get a value out of that matrix, just like with vectors, we use indexers here. Since we have now introduced a second dimension, we need a second index. If we want to get now diet track, if you want to get the value for, okay, we are interested to know how much carbs we had on the 3rd day. Well, we open brackets, and now our first argument is the row. So which row are we going to look for? We know that the carbs are on our 2nd row, so we're looking at row 2nd, at row 2. And since we're looking for day 3 is column 3, so we supply 3. So this should give us 280. Let's run it. And there we have it. The first index shows the row. Which row are you looking for? And the second, the column. Wherever these two numbers cross, this is the value that you will get. If you want the 4th row, 4th day, so the calories for the 4th day, you will use 4 and 4.